So the PMC engine, I have found some information about it for PatchWork, the PW constraints, and it was created uh, by Mikael Laurson and was ported partially to OpenMusic by Arjan Sander, if I'm correct. Uh, I the first step, I was reading the documentation from PWConstraints, and I have found some interesting materials, but it's in very different language. For example, the code to calculate the all interval series is this code. That's very different from the visual patch, right? That's the same for PWGL. There's some others libraries who works with uh, constraint solvers, but the main obstacle was to transcribe this to a visual patch inside OpenMusic. So we have to understand two things about main things about the PMC engine. The search space, that is the number of variables, and the number of candidates for each variable. Or each variable is made by a list of any number of elements, and you will repeat that list by the number we repeat for the number of variables you need to use or want to use. I have prepared a little example. Imagine we have a list with 4 numbers, 1, 2, 3, 4. So I will repeat that list 4 times, right? So here we have the search space, 4 lists of 4 numbers. There is another thing that is important, that is the solution mode. You can ask for only one solution with ons, or if you want, you can get all solutions. So with I evaluate now, I have all possibilities between these 4 numbers, right? So it's not so complicated. I have 4 lists, the number of candidates of each list, and then it calculates all possibilities, taking one number from each list. So now you have to create some rules, and these rules is to select some of results that we need. For example, this is one rule that I've taken from the PWConstraints and PWGL. That is, this is one possible solution, and we have for each new selection this calculation. So I will reverse the solution. So we'll take always the last element of it. We'll remove the last element, that is the first. This is not correct. Now it's correct. The 2 and 1. So the number 3 is not here because we remove it. And we will select only those numbers that it's not a member of this. So this will give new because the number 1 already there, right? If we use another result from 2, 3, and 4, for example, we have this, and now it's true because it's not a member of this list, right? So this patch, I don't know, I think it's this. Yeah. this patch is a rule. This rule is created by a Lambda patch, and this Lambda patch is connected to the wildcard rule. That's a rule that will be applied to each variable, right? So if I use this rule here, I'm sorry, so only talk about this Lambda patch before. So we'll take any candidate and test if it's not a member of the CDR of the partial solution. It's a little bit tricky, but it's exactly what you have done here. The reverse of the list, take the CDR and test if it's a member or not. In this case, we don't want that it's a member, so we use the not for this dispatch. So if I evaluate this now, I have only permutations with no repetitions. So this rule was applied to that four lists of our search space, right? And this can be bigger, of course. For example, the next rule, it's by intervals. So we have to check, again, the reverse of the partial results, take the second and the first, and calculate this interval, modulo 12. And we will check all other intervals of the same result, modulo 12, remove the first, and check if this interval is a member of this. So this is the second rule, right? So this one is to get only new elements. This one is to get only new intervals, right? And this is the rule that was created here. So again, for every number, we will check if it's a new number and if it's a new interval, right? And for the rules, we have to use the list. We create one new list with the true rules that will be used here, right? And this one here, I forgot to say, is the random. If you want that the results are chosen randomically or not. So I have this. This is the only, the results show new elements and new intervals. There's no repeated intervals, right? It's very, for me, it's very interesting how this worked, you know, and I decided to study more. I'm still studying about this. There's different rules. Unfortunately, I don't know enough to talk about it, but that's the generic rules, the heuristical rules, and forward checking rules. But with these two rules, it was possible to calculate the interval series, because we don't need repeated intervals, and we don't need repeated nodes, no duplications. We have only to change this, that is the search space. So if we check the PW documentation, this is the search space. We have a list with only one element, the 0. We have 10 lists from 1 to 11, skipping the number 6. These 10 lists are equal. And in the end, we have a list with 6 only one element, that is 6. That's because the all interval series have this interval, always have this interval, 0 to 6. So what you have to do is to take that list, repeat 10 times, right? And we can use the 0 and 6. It's exactly the same search space that it's on the PW documentation. The first list, 10 times from 1 to 11. And then we can search with this search space. We can search for the all interval series with the same rules, no repetition and no interval duplication. I will use length to see what's happening. It takes some time. If it works, yeah, works. 3,866. Okay. 56 possible all interval series. Right? I use another kind of rule, that is the index rule. That is different to the wildcard rule, because it's not applied to each variable. It's only the number you select. Let's say the first, the second must be 5, for example. So we have this rule. I don't know where. Only one output. And I will create from the OMCS index rule. Right. The first is the rule. Right? Lambda patch. We will check the number, and we'll see if we equal 5. And here I will select what variable I want to use this rule. For example, I want the number 5 will be the second number. If I use this rule, I think I will get only those all interval series that have the number 5 on the second number. So I have these two basic types of rules. The wildcard will be applied to every variable, and the index rule, you can select this to what variable you want to check this rule.